Hello, this video is going to be from Miss Vaughn's 8th grade pre-algebra class. I am going to go over some final problems for section 3.6, which is talking about sets of numbers and inequalities. So we did this lesson on January 19th. So if you missed that day, this would be a good video to watch. What I'm going to do is I'm going to go through the homework problems for this section. We're going to work through those together. So go ahead and have your book open to page 119. But then set it aside for just a second and make sure you have your scratch paper, notebook, or binder open and ready. I'm going to go through some additional problems that are not in your textbook so that you have them for reference when we do quizzes and tests. So let me go ahead and share the screen with my whiteboard, and we'll go ahead and get started here. Let's see. There we go. All right, so let's get flipped around. And not auto rotate. There we go. Okay, so like I said, section 3.6, additional, if I can write, additional problems. Okay, so if you remember from last week, what we're going to do is I'm going to give you an equation for the first 6 problems here, and I'm going to give you a set of numbers. So remember back on what we talked about, natural numbers, whole numbers, integers, rational numbers, and irrational numbers. You can reference page 116 in your book if you want to look at that Venn diagram again. But we need to determine for these problems and these equations, is the solution that is given, is the solution fall into the set that we've asked? Let me just show you here. It's been a long day. I'm gonna be stumbling over my words through this video for sure. Okay, so if I give you the equation negative 4x equals 20, and I ask if the solution for x is gonna fall into the set of whole numbers. So remember that whole numbers are all positive numbers, 1 to infinity, but it also includes the number 0. So if you look at this, you know that to solve for x, you need to do the inverse operation of multiplication, which is division, negative 4 to both sides. Now, in the instructions you're going to see in many cases, it's going to tell you to determine if the solution falls into the given set. And if it is yes, then they ask you to solve it. Well, now while we're still learning this process, I know a lot of you would much prefer to solve it to find out if it falls into the set that they're asking you. So we're going to go ahead and solve it. X equals negative 5. Is negative 5 a whole number? Well, we know that it's not because it's negative. It's only an integer and larger. So the answer to this one is no. Number 2, they give us negative 3 plus x equals 10. Now, try to solve for x in your head. This one is pretty basic. It's subtraction and addition, so you probably can do it. We're also going to see, or excuse me, we're also asking, does this fall into the whole number set? Now, we know that what we need to do to isolate x is to add 3 to both sides. Well, if you do that, you end up with x equals 13. 13 is a whole number. So the answer here is yes, it is a positive whole number. Therefore, we would solve it. So we add 3 to both sides. X equals 13. Yes, that is a whole number. So you have 2 answers to that problem. Number 3, x divided by 3 equals 4. And they're asking, does this fall into the set, the integers? Well, in this case, the answer is yes, because you multiply both sides by 3 to isolate your variable, and x equals 12. 12 is an integer, therefore your answer is yes. So you have both of those as well. Number 4, 5m equals 8. You know what, let me go back to number 3 really quick. So we talked about this last week because if I gave you the number 12 and I asked you to tell me where on the Venn diagram does 12 fit, then your answer should be, or excuse me, what is the smallest set that the number 12 fits into? Your answer would be natural. 12 is a natural number. It is a positive whole number, or whole integer. Therefore, the smallest subset that it fits in is natural. But as we remember from that diagram, all natural numbers are whole numbers. All whole numbers are integers. All integers are rational numbers. And then all rational and irrational numbers are real numbers. So it is still in the integers because it is a natural number. But if I asked you to put it on a Venn diagram, you would want to make sure you saw that its smallest set on that Venn diagram is a natural number, and that's where you would place it. Okay, moving on. So if I give you 5m equals 8, and I ask you to check, does this fall in the category of the integers? You can look at this and see that in order to solve for m, you would need to divide both sides by 5. So you would get m equals 8 over 5. Now, 8 over 5 does not reduce into a whole integer, negative or positive. Therefore, it must stay a fraction. So this is not an integer. So your answer here is no. Now, if we went ahead and solved this, so you can see that, that is the solution we get for m. We see that we have an integer over an integer. So these are both in the integer categories, which we represent with a z. That by definition means it is a rational number, but it is not an integer. Okay, number 5. So number 5 asks x squared equals 10. And we want to know, is this a rational number? Now, the inverse operation to an exponent is the square root, or in this case, in the inverse of squared is square root, and then of course you would have the equivalent number on the outside of a square root if it were x to something else. So the square root of x squared is x, so it isolates our variable, and our variable equals the square root of 10. Now, if you use your calculator and punch in square root of 10, you're going to find that this is an irrational number. When you solve it into decimal, this number never ends or never repeats. So in this case, we know the answer is no. Square root of 10 is not a rational number. All right, number 6 asks us to solve 4x equals 15 and to determine if this is a rational number. Now, when you're determining whether something is a rational number, you don't have to solve the fraction and turn it into a decimal, because by definition, a rational number is any integer over any other integer, as long as b does not equal 0. Because remember, if you have 0 in the denominator, then your answer is undefined, and you'll get an error message if you try to put that into your calculator. So if we solve this, we know that we divide both sides by 4, and so x equals 15 over 4. Is 15 an integer? Yes. Is 4 an integer? Yes. Therefore, x equals 15 over 4 is a rational number. So your answer is yes. Okay, so the second part of these additional problems asks which numbers are members of the solution sets for the given inequalities. Let me just write that out so you can see it. I think once we do it, you'll know what I'm talking about. Sets. So remember, inequalities involve greater than or greater than equal to, less than or equal to. So you can have more than one solution that is a true statement for a particular inequality. So for number 7, if I have x plus 6 is greater than 14, and I give you the numbers negative 20, negative 8, 8, and 20. So first, particularly when the inequalities are fairly simple, like this, then you can look at this and say, okay, if x equals 20, then that's 20 plus 6, which is 26. And I know that 26 is greater than 14. So this tells you you can start with your larger number first and then go down instead of starting with your smaller one. So if we did that, we would plug in that value. Let me just make multiple. So let's do this. So x plus 6 greater than 14. 20 plus 6 is greater than 14. 26 is greater than 14. Is that true? Well, yes, it is true. So I just put a little t over my 20. Now let's keep going. Let's try 8. So if I have 8 plus 6 is greater than 14. And so I solve that and I see that 14, this statement tells me that 14 is greater than 14. And is that true? Well, no, 14 is equal to 14, which means it cannot be greater than. So 8 is false. Well, now that I know that 8 is the number that would plus 6 would equal 14, any number smaller than 8 is always going to be a false statement. So and I put a true over it. Hold on. That should be false. Therefore, I know that negative 8 plus 6 is going to be less than, because it's negative 8 is smaller than 8. And I also know that negative 20 is going to make this true statement false. So I don't even have to calculate those because I know I sort of found my middle ground here. So I know that I can't go any lower if that one is false. Therefore, you can set your answer to 20. 20 is the only number in this set of numbers given that makes x plus 6 greater than 14 a true statement. And we're done. So let's look at number 8. So number 8 gives us negative 3 times x is less than or equal to negative 24. For the number set, negative 9, negative 8, 8, and 9. All right, so look at your inequality. So you know that we need numbers that are going to be smaller than or equal to negative 24. We also know from chapter 1 that any negative number times a positive number equals a negative number, and that any negative number times a negative number is going to equal a positive number. So we already know that negative 3 times negative 9 is going to be positive, and any positive number is going to be greater than negative 24. So we already know this is going to be false. Same thing with negative 8. Negative 3 times negative 8 is going to be positive 24, much larger than negative 24. So we can go ahead and call this false. So let's go ahead and start with 8. If I have negative 3 times 8 is less than or equal to negative 24. So negative 3 times 8 is negative 24. And we know that that's going to be equal to negative 24. Therefore, this is a true statement. 8 is true. All right, so let's plug in the value of a positive 9. Negative 3 times 9, is that going to be less than or equal to negative 24? So 3 times 9 is 27, and we know this is negative because one of our factors is negative. And remember that any negative number, if the greater the number that's negative, the smaller its value is on the number line. So negative 27 is 3 numbers smaller in value than negative 24. So this is also true. Check mark. Try to stay consistent here. Therefore, for number 8, The numbers that make this a true inequality are 8 and 9. And that's your answer. Do that here too. Okay. So 2 more. Let's go ahead and get through these. Number 9 gives us k plus a negative 12 is less than 0. With the numbers negative 12, 0, 12, and 24. All right, so for this one, we plug in the values. Now, you can look at it if you want, but one thing you're going to see, if you go ahead and start with the negative 12, then you have negative 12 plus a negative 12. And I'm going to leave it in this format just to show you what we're adding together. So when you look at that, you can see we are adding like terms. Now, another way that this would be written, and the way that this would normally be written, is negative 12 minus 12. So recognize that these two things are equal. So negative 12 minus 12 is the same thing as negative 12 plus a negative 12, which means you are adding like signs so that you add them together. What that means is your answer becomes negative 24 is less than 0. Now, we know that any negative number is less than 0. Therefore, this is a true statement. So we know negative 12 is true. Now, let's go ahead and put in 0 for the value of k. 0 minus 12 is less than 0. Well, what's any number added to 0? It's that number. Therefore, the answer to this is just negative 12 is less than 0. Again, we have a negative number, which is going to be less than 0, so that's a true statement. All right, so let's plug in 12. 12 minus 12 is less than 0. Well, any number minus itself is going to be 0. And we know that 0 is equal to 0. Therefore, it cannot be less than 0. So this is a false statement. And so now we know we've reached our cutoff point. We've reached our point of equality. And so any number larger than 12 is going to be a positive number. Therefore, it must be false because no positive number is less than 0. All right, so your final answer for number 7 is negative 12 and 0. Both of those values for k, in this case, are true within the inequality given. Okay, last one. Number 10, we're given that 4m is not equal to 16. So they've given us the numbers negative 4, 0, 4, and 16. So again, these are fairly simple inequalities. So let's just look at them. What value would m be for 4m, 4 times m, to equal 16? Well, we should know that 4 times 4 is 16. So the only statement that is not true here is the number 4. Because 4 times 4 is the only thing that equals 16 within this inequality. Everything else is going to give us a different number. We can go ahead and work through those to confirm our answer. But in this case, you can look at this and already know what's going to be true and what's going to be false. So let's put in negative 4. 4 times negative 4 is not equal to positive 16. We know this is true because any positive number times a negative number is going to equal a negative number. And negative 16 is not equal to 16. So that is false. Let's put in 0. 4 times 0 is not equal to 16. This is true because any number times 0 is 0. 0 definitely is not 16. Therefore, it is false. Or excuse me, true. Okay, and then plug in 16. So 4 times 16 is not equal to 16. 4 times 16 is 24. 64. 64 is not equal to 16. Therefore, when you write the answers that make this inequality true should be -4, 0, and 16. Okay, now let's go ahead and keep out your scratch paper so you can work through these. I would suggest that you go ahead and pause this, and now that we've worked through some of these, try doing the homework assignment on your own after I give it to you. But definitely check your answers along with the video, whichever you want to do. So in this case, give me a second to catch myself up here. Okay, we are doing numbers 14 through, not 38, 32 even. And those are on page 119. All right, so if you haven't already tried, go ahead and give those a try. If you have, then just skip along and check your answers as I work through these. So number 14, for 14 and 16, they have given us a equation and have asked if the solution to this equation is true over the set of integers. So is your solution an integer? So number 14 says 4y equals 18. Now, you can look at this and see that your inverse operation that needs to happen here is to divide both sides by 4. We know that 4 does not go evenly into 18, so your answer is not an integer. Therefore, the only real answer you need to give is no. Now, if you do not recognize that immediately by looking at this equation, go ahead and work it out. 4, this becomes 1, therefore y equals 18 over 4. So it's a rational number, but because it is not a positive or negative whole number, and it's not 0, it has to be expressed in fraction or decimal form, then it is not an integer. So the answer is no. Number 16. Number 16 says x over 5 equals 2. Well, immediately you can see your inverse operation here is to multiply. 2 times 5 equals 10, and that is definitely an integer. In fact, that's a natural number, which is the smallest subset of numbers that we have for this lesson. So it's definitely an integer. So x equals 10. We're going to go ahead and prove that we're right, and your answer is yes. All right, so for number 18 and number 20, we are asked to check our solution to these equations and tell us, are they rational numbers? Do they fall in the set of rational numbers? So number 18 is 3x equals 2. And you can look at this and immediately see that when you solve for x, you're going to end up with an integer over an integer, and that is by definition a rational number. So yes. All right, so for number 20, we have -5, x equals -8. All right, so again, you see here that you have, you're going to divide both sides by -5. So you're going to end up with x equals -8 over -5. You can go ahead and simplify that to x equals 8 over 5, because remember, a negative divided by a negative equals a positive. So we know we're gonna be correct, so we're gonna have to go and solve for it. So x equals 8 over 5. And yes, this is a rational number. You have an integer in the numerator, you have an integer in the denominator, you're all good. We meet all the requirements for rational numbers. Okay, so for number 22 through 32, we're doing similar to what we did to the last 3 problems earlier. We are going to be given an inequality. We're going to be given a limited set of numbers, and we need to determine which of those numbers makes that inequality true. Okay, so number 22 says 7x is greater than 49. For the numbers 4, 8, 10, and 11. Now again, look at this inequality. You should be able to see the relationship between 7 and 49. 7 times 7 equals 49. If you've memorized your multiplication tables, this is easy to see. So you know that 7 times 7 equals 49. Therefore, any value for x greater than 7 is going to make this inequality true. So if we do that, we can go ahead and say that 8, 10, and 11 are true, and 4 is going to be false. Now, I'm going to go ahead and work these out to show you, to prove that what we just determined is true. But go ahead and practice looking for those relationships between the numbers and solving this mentally, and then check your answers by going ahead and working through the inequality. All right, so let's go ahead and start with 4. 7 times 4, is that greater than 49? Well, 7 times 4 is 28. 28 is not greater than 49. Therefore, this is false. Plug in for 8. 7 times 8, greater than 49. 7 times 8 is 56. It is greater than 49, so this is true. 7 times 10, greater than 49. 70 is greater than 49, therefore we are true. Last one, 7 times 11, greater than 49. 77 is greater than 49, so we're true. So your final answer that would go on the answer line on a quiz or in your homework would be 8, 10, and 11. Like I said, I encourage you to try and do these in your head, but I also insist that you check your answers until you feel completely confident that you have understood this process, because eventually we're going to get to some inequalities that are going to be too complex to do mentally in their entirety. And so you need to remember what that process looks like. Okay, number 24 is x divided by 4 is greater than or equal to 3. Again, if you know what number does 4 divide into that equals 3? Well, we know that 4 times 3 is 12. Therefore, if x is 12, then this is a perfectly balanced answer. It means that 3 equals 3. So any number greater than 12, 4 will divide into it more than 3 times. So it will be a greater value than 3. So if I give you the numbers -7, 10, 12, and 15, you're going to know, we know that 12 is that perfect balance, that's equality, because that gives us 3 equals 3. And then 15 is the only other number in our set that is greater than 12. So those are the only 2 numbers that are going to be true for this make this inequality a true statement. The rest are going to be false. Again, I'm going to test the 10 and the 12, right? Because that's sort of our median numbers here, to show that one is definitely false and the other is true. So if I put in the value of 10 divided by 4 is greater than or equal to 3, well, I know that 4 goes into 10 for 2 times, it's 8, and then there's 2 left over. 4 goes into 25 times. So this becomes the statement 2.5 is greater than or equal to 3. We know that is false because 2.5 is less than 3. So then I put in the 12. Let's make sure that we know what we're doing here. It's late in the day and my brain is getting a little slow. So let's see, 3 is equal to 3. Therefore, this is a true statement. And then, of course, once we've determined that that is true, then we know that any number greater than 12 is also going to give us a solution greater than 3. So those will be true. So your answer would be 12 and 15. All right, number 26. 26 says 13 is greater than z over 3 for the values of -8, 20, 39, and, hold on, I lost my place, 40. Okay, so can you see a relationship between 3 and 13? Well, 3 times 13 is 39. If you see that, then you know, excuse me, then you know 39 divided by 3 equals 13. And 13 cannot be greater than itself. Therefore, we know that 39 is going to be false. And any number smaller than 39 is going to, or excuse me, larger than 39 is going to be false because it's going to give us a value greater than 13, not less than 13. So again, we'll do like I did in the previous one. I'm going to solve the solution plugging in the two middle numbers to kind of show which one is true and which one is false. And so then you can see how we prove this. So if I put in 13 is greater than, let's do the 39 first. 39 over 3. 3 goes into 3 one time. 3 goes into 9 3 times. Well, we know 13 is equal to 13. Therefore, 13 cannot be greater than 13. So this is false. So let's put in a value for 20. 13 is greater than 20 over 3. So let's see. 3 goes into 20 6 times because that's 18. And so then there's a 2 left over. And so then it's 20 again. So 6, and then 20 again. So it's going to be 6.6 to infinity, repetitive. So we know that 13 is significantly greater than 6.6. So 20 is true. And then, of course, we also know that any number divided by or into, excuse me, let me just start that over. Any positive number divided with a negative number equals a negative number. And we know that a positive 13 is going to be greater than any negative number. Therefore, negative 8 is also true. So your final answer is negative 8 and 20. All right, let's do 28. Negative 4x is less than or equal to 20. All right, for the numbers, negative 10, negative 5, 5, and 10, I think. Yes, okay. So again, we see a relationship between 4 and 20. Negative 4 times what equals 20? Well, negative 4 times negative 5 equals a positive 20 because it's negative times a negative is a positive. So we know because of this greater than or excuse me, less than or equal to part, the negative 5 is true because that gives us the equals. Yeah, that gives us the equality. Let's say it that way. Now, if we need to stay smaller than 20, well, we know a negative 4 times a negative 10 is a positive 40, which is much bigger than 20, double the size, so that's not going to work. So let's just go up. So if we did negative 4 times a positive 5, is that less than or equal to 20? Well, yes, it is because that's negative 20. Therefore, it's smaller, so that's true. Let's plug in the positive 10. Negative 4 times a positive 10 is going to equal a negative 40, which is definitely smaller than a positive 20, so that is also true. So you can see that any number multiplied by negative 4 that is equal to or greater than negative 5 is going to give you a true statement here. So your true answers are negative 5, 5, and 10. All right, 30. So number 30 says negative 32 is greater than y over 7. All right. Negative 32 is greater than y over 7. Okay, for the numbers, negative 200, 0, 100, and 200. Now, we don't see a very clear relationship between 32 and 7. So let's go ahead and solve for y. And then I'll show you how to solve for y over inequality and then make a comparison between the numbers. So if I do this to solve for y, to isolate y, we're going to multiply both sides by 7. It's our inverse operation. And so y, we'll just leave that guy there for now. 7 times 32. Let's go ahead and work it out. Negative 32 times 7. 7 times 2 is 14, carry your 1. 7 times 3 is 21, plus 1 is 22. Negative. So y must be less than negative 224 for the statement to be true. Now, you can see from these numbers here, are any of these numbers given smaller than negative 224? Obviously, the answer is no. Therefore, these are all false. So when you're writing that answer on the number line, you would just say none. None of the numbers given in the limited set you've been given make this inequality a true statement. All right, number 32. Number 32 says 42 is greater than or equal to y over 10. And we want to check that with the numbers 4.2, 10, 100, and 420. So again, with this one, let's go ahead and just solve for y. So you do it sort of exactly like an equation, but you keep the sign, keep the inequality sign the same, and it creates a true statement. And then you substitute those numbers in for y to determine whether they work for that inequality. So we're going to multiply both sides by 10. Y must be less than or equal to 42 times 10, which is 420. Again, let's look at our numbers. Are all of these numbers less than or equal to 420? Yep. All true. So because they're all true, on your answer, you would just put all of the numbers. So 4.2, 10, 100, and 420. Now, if you would like, go ahead and plug those values into your original inequality and then solve and see if it comes up with a true statement. You will find that all 4 of these will work. All right, so that is our lesson for today, for the 19th. If you have any questions, jot them down so that you have them for a reference when you come back into class, and keep an eye out either later tonight or tomorrow for a video to go with tomorrow's lesson. Let's see, pre-algebra. Yeah, we're going to move on to section 3.7 tomorrow. So I will definitely have that ready for you. Thanks so much, and I will talk to you later. Bye.